Okay, so this is the last lab, okay, in this semester. So more logical gates. For this one, we will use two chips, 7432 OR gates and 7486 XOR gates. So for this lab, we won't do the OR lab. So for you, just need to do the step one from step one, two, and three. Okay, so just step one, two, three. Okay. Okay, so for the first one, here, just go to this page. So step one, so actually you need to find the OR gate, the truth table. Okay, so two inputs, 0, 0, 0, 1, 1, 0, 1, 1, then find the output and also the voltage. Step two, so it's for find the XOR gate, the truth table. Okay, similarly. Then step three, so it's here you need to input a signal, a square wave, then draw the output, okay, with the different situation. Okay, so go to step one first. Okay. So this is the chips, the pinout. So 32 crowd, two input OR gate. So there are four OR gates inside. So just this one, pin 1, pin 2 are inputs, pin 3 is output. So then pin 7 connect to ground, pin 14 connect to the power, so VCC. 86, so crowd 2 input XOR gates. So similarly, for this one, pin 1, pin 2 are inputs, then pin 3 is output. Similarly, pin 7 connect to ground, pin 14 connect to the power, VCC. And for the circuit diagram, I draw here. So use 32 as an example. So two inputs, right? So we connect to LED resistor, then power. This is the switch, then connect to ground. So this means if the switch is open, then this point connect to the power. So then input is 1. If the switch close, then this point connect to the ground. So input is 0, so low. So use the switch, change the input status. Then for the output, so LED resistor, then power. So this means if the output is 0, then LED will be on. Just remember, so LED 0, so output okay. So output 0, then LEDs are okay. This is because when output 0, then at this point, we know the voltage is around the 0 volt, right? Then 5 volts, 0 volts, so the voltage across the LED should be greater than 0. So then the current can flow through LED, so LED is on. Okay. Then if the output is 1, okay. Then if output is 1, so we know at this point, the voltage is around 5 volt. 5 volt, so the 5 volt. So this means the voltage across the LED should be around 0. So 0, then LED is off. Okay. So just remember, so LED on, output is 0. LED off, the output is 1. Then we also will use the multimeter measure the voltage at the output side. For input side, so this is open, similarly open. Then this point is the high voltage, so input is 1 and the LED is off. Then switch close, then this point connect to the ground, so input is 0 and LED is on. So we will use this one, build the circuit in the Tinkercad. So this is the step 1. Then step 2, just replace the chip with the 86 XOR gate. Okay, this is the step 1 and step 2. Step 3, so you need to build the circuit like this. Similarly, okay, just pin 1. So pin 1 now connect to a switch, just like before. But pin 2 now is input a signal. We said before. So this is use the square wave signal. So this is for the pin 2. And for this one, for the square wave pin step 3. Okay, this is the 1 kilohertz. So the square wave is the 1 kilohertz. And for the magnitude, so you could use 2, 4, or 5 volt. No, greater than, greater than 5 volts. Okay, because for the chip, usually the input, the maximum voltage is the 5 volt. Okay, so let me build this first. Okay, so first one, 32. Okay, close this. Change the name. So lab 06. Okay, so maybe because I will do 2, so this is 1. Breadboard, then this is not function laser, we just need a power. So this is the DC voltage source. Okay, then zoom out a little bit. So first one, I just connect the power lines from the power. Okay. Okay, so now power lines are connected, so positive, negative. Then we need the registers, so 330. So for this one, I could use this way, right? So this is the positive, so positive go down 330. Then LED, so we need just get 2 more first. Not too close. So 330. The color is different. Oh, I typed wrong. 330. Okay, then LED. So just remember LED has the direction, okay? Cathode, so this is the negative, anode is the positive, okay? So rotate this. Okay, so this is positive, this is the negative. One more. Then resist, let me think, so let me go bit up. Okay, don't build this first. Because of we still need a switch, so let me put switch first. Okay, so one, yeah. So now I just use the switch 1 and the switch 3. Then put this in. Oh, no. Okay, so actually I use the switch 2 and the switch 4 because this is LED. Okay, so LED positive, negative, now connect to the 4. Okay, 2 and 4. Then we need to connect to the ground. Okay, so this one, then let me think, because these holes are covered, so I cannot. Okay, let me move to this position. Rotate back, flip, then go up. Okay. Okay, so just make sure positive connect to the resistor, negative then connect to the switch. Go back here. Okay, let me double check. Okay, then we have, yeah. So now we can use these lines connect to the chip. So 32. So I need to get, this is 32. So any position. So 32, first let me connect pin 7 to ground, pin 14 to power. So this is red. Okay, so this is yeah, power and ground. Then for the 32, we know pin 1, pin 2 are inputs. Pin 3 is the output. Okay, so then pin 1 and pin 2, so let me change the color. I usually use green. Oops. Over here. So input, let me use this way. So need to connect to the point. So here, the point after LED. So the negative pin out. Then I can change this. This one go here. Because we need a pin 2. Okay. Pin 2. Oops. So, okay, it's from here. Okay, so this is the pin 2. Then pin 3 is output. So we need a resistor and LED again. resistor, maybe from here. So 330. Then LED. Okay. So flip. Oops. Okay. Then this one, so the negative can go down a little bit. So the negative terminal of LED connect to the pin 3 output. So let's go here. So pin 3, this is output. Oh, this one 5, so voltage 0, offset is 0. Oh, no. This is current. Doesn't matter. So voltage, make sure is the 5 volt. Okay. Then we can start simulation. So in this way, oh, I forgot the meter. So we need one more meter. We need to measure the voltage at the output side. Just okay. So negative can connect to the ground. Positive now go to the output. So this is output. Okay, can go here. Okay. So this is this 921, right? Connect to the output. Okay. Okay, so now let me. Okay, so you can see now the switches are both switches are open. Open, we said before, these 2 points are 1. So high voltage, these 2 are connected to the power. So that's the high voltage. So that's the high. So 1, 1. For all gate, 1 plus 1, output is 1. 1, so this point actually is here. The output voltage, so is 5. 5, so voltage across LED is 0. 0, so LED is off. So for this one, for all gate, we know if any input is 1, the output is 1, right? So now we have to close 2 and 4. Switch 2 and 4 are closed. So both inputs are 0. So output is also 0. Then this is now the LED is on. Okay. So output 0, so LED is on. Then you can change this status, then field truth table. Okay, so this is this one. Okay, so then let me go back. So change it, create another one for step. Step 2, you just need to replace the chip with the 86 XOR gate. Okay, then let me go to this. This a little bit different. Okay, this one. So for this one, because we need the power and also the function generator. So both of them. Oh, let me change it. So actually this is for step 3. So I typed 3 here. Power. So we need the power and the function generator. Okay, this is just one resistor, so 1 kilo ohm resistor. Oh, let me connect power first. Power line, positive. I didn't change. Okay. Then LED, so no, register. So register just 1 kilo ohm. So just need to put here. Then we need a switch. So switch. So switch, we can this now. Okay, so I use switch 1, then connect to the ground. Okay, yeah. So we finish the input 1. So then the chip, so 86. So 86, 74, HC 86. This is the XOR gates. Okay. So this is the same. First, pin 7 to ground, pin 14 to power. Okay. Then, so input. So input 1 connect to the switch and the resistor. So actually from here, the point between resistor and the switch. So this is pin 1. So pin 1, pin 2 are inputs. Pin 3 is output. Then pin 2, so this one, so need to connect to the function generator. So from here, so this is 1 kilohertz, 5 volts. So square wave, this is okay. So 5 volts, okay. 2.5, this is okay. So this means the square wave then is from 0 to 5, 0 to 5 volts. So this is one we need. Okay. Then negative, so just need to connect to the ground. Then positive, so we need to go to pin 2. Okay, so this is the pin 2. Then let me change this black, this to red. Okay, just a moment. Okay, so now this is the input signal, so should be a square wave. The output, so is pin 3. So is pin 3. This is the output. Connect to LED, connect to a resistor. So we need a resistor now. Okay, in position. So this is 330. Okay. Then LED. So I need to flip this. So okay, so this is positive, then negative. Okay, so negative, then go to connect to the pin 3. Oops. Okay, let me just delete this. So this is circuit. So actually we still need one more because for the here, we need to get the output signal, right? So output signal, so this means we need a function generator. Observe the output signal. So we need a, no, oscilloscope, sorry, oscilloscope. So oscilloscope. Okay, so this is positive, so go to here. So this is the output, okay. Then negative, so just need to go to ground. Okay, so this is the circuit. Okay, let me run this. So first of all, I need to change this. Okay, so this is 1 kilo, too large, 1 still large, 10, too small, 50, 50 still is small, 100, okay, too small, 500, too large, 200, okay, 200 is okay. So actually we could use 5. So, but now, okay, so we need one more function generator here. Because for the real oscilloscope, we could input the 2 signals in, and so can show these 2 signals on the one screen at the same time. But in Tinkercad, we cannot do this, so we need 2 signals, 2 oscilloscope. Okay, so positive, so go to the input. So this is input signal, right? Then this is just go to ground. Okay, so then we can compare these two. Okay, so this is also 5. Okay, so you can see now we can compare these 2 signals. So now just remember, now switch is open. Switch is open. So now this switch is open. So switch open. So this pin 1, the input is 1. So it's the high voltage. So now switch is open. So open, so you can see the output signal is the same as the input signal, right? So low, low, high, high, low, low, high, high. So the same as the input. So for here, you just draw the signal. So now switch 1, S1 is open. So output is the same as the input, okay? Then the last one, so we need a close switch. Okay, no change. Let me stop simulation, start again. This is so weird, no change. Should have some changes. Yeah, so it's still low, high, low, high. Let me double check. So, yeah, I'm not sure because because the function, the oscilloscope, or because the Tinkercad. So actually, this one should change. this is the XOR gate, so 86. So XOR gate, if you remember, if inputs and outputs, so inputs the same, the output, so it's just 0. If input is different, the output is 1. So this is the XOR gate. So this means just for example, now for this one, switch is goes to the connect to the ground, right? So this means for here, the input is 0. So just remember, I can draw here. So input is 0. So now 0 and 0 is the same. So output, so let me write down here. So output is just 0. Okay. Then the last one, so 0, 1, 0, 1, right? So different. So output, so is 1. Then output is 1. Then same, so 0, so go here. Then different 1 and 0. So then output so should like this. Okay, so same, then same, so is output is 0. Different, so output is 1. So this is for switch close, switch close. Then if switch, so this is switch, now is closed. If switch is open, so let me draw here. Then this is the 1. The input is 1, right? Okay. Then for the output, so for the output, so now 1 and 0, so different. So output is 1. Then 1 and 1, so inputs are the same, so 0. Then the same, so 0, 1, so input is 1, output is 1. Then same, so is 0. Okay. So you can see here. So actually, when you change the switch position, the output should be flip, okay. So change the direction, but Tinkercad, this one doesn't change, so I'm not sure. Okay, so let me double check this. Let me use the meter. So positive go to the input side. Negative just go to ground. Let me play. Yeah, so this is 0, 5. Yeah, so input side did change. I think this is because for the always for the Tinkercad, he always change the signal position, output position. He always use the 0, the low value, low value as the starting position. Okay, so now, in Tinkercad, so we cannot show this. Okay, so this means for you, okay, just do step 1 and 2. So you couldn't get this in Tinkercad. Okay, so just do the step 1 and 2. So just fill the truth table. Okay, these 2 truth tables. Okay. Then the later, so I will try this in the multi-sim. Okay, and show this to you. So multi-sim should work. Okay. Okay, so you can start now. Okay.
Now we just have to pull 5.2, 5.3.